This question is testing your understanding of potential divider circuits and potential difference and general understanding of how potential will be shared across components in series. So we have this setup, and I'm just going to sketch it out just so I can annotate it a little bit more easily. So we have this, and we have two resistors along the top, and we have two resistances. So one's a thermistor, that doesn't really matter. One's a thermistor, and the other one is just a resistor. And we're told that if we connect this up, these 2 points up with a voltmeter, the voltage is 0. Now, what that means is it doesn't matter what this potential difference is or the EMF provided to the circuit is. What that means is that the ratio of P to Q is the same as the ratio of R to T. So V will always be 0 if the ratio of P to Q is the same as R to T. Now, in terms of me explaining that, that could be that the easiest way to think of it is that P and Q are equal. So if P and Q are equal, and then R and T are equal, that will give you a voltage of 0. P and Q don't have to be equal to R and T, but they have to be equal to each other. Because if I set this to a voltage, let's say 6 volts, an arbitrary choice doesn't make any difference, but say it's 6 volts, then what I can say is that this section on the positive side, it would make sense to say this is 6 volts. And everything connected with a wire has to be at the same potential. So this is at a potential of 6 volts as well, and this is at a potential of 6 volts. This side, all at 0. All at 0, everything connected up with a wire is 0. So all of this side are at 0 volts. Then, if these are equal to each other, half of the voltage will be dropped, and then the second half is dropped here. So it will be 3. If P is equal to Q, it will be 3. If R is equal to T, it will be 3 here as well. So it doesn't matter what R is. R could be a billion. If R is a billion, T has to be a billion. It's 3 volts. P could be 4. If P is 4, Q is 4, and that's 3 volts. So as long as those two are equal to each other, these pairs that are in the same branch are equal to each other, you'll get the same voltage. Now, the other way of doing it, which is a bit more flexible, is any ratio. So it could be 4 to 2, or that's 2 to 1. So 2 to 1, if this is in a ratio 2 to 1, that voltage will be 0. So if P is 2 million, Q is a million, R is 2, T is 1, the voltage will be 0. So it's working in these pairs and understanding that's how the voltage is split across the pairs. And when I've explained this in class or to my students, you can treat these branches entirely separately. It's as if they're separately connected to this 6-volt power supply and they don't know each other are there. So what happens in the question? So it's a thermistor. The temperature's increased. So negative temperature coefficient thermistor, temperature increased, therefore the resistance falls. The resistance of T falls. So the resistance of T has fallen. So the resistance of T goes down. So now T gets less of a share of the voltage. So R gets more of a share of the voltage. So in my example where it went 6 to 3 to 0, it might be going 6 to 2 to 0. So this is now 4 volts, and this is now only getting 2 volts. If this is 6 to 2 to 0, then we've got 2 here, and if these two stayed the same as each other, then that's 3, and now we've got a 1 volt. And there's a number of different ways of rebalancing it so they match again. So T's gone down. A way of rebalancing it is for R to go down by the same proportion. So if R goes down by the same proportion, the resistance goes down by the same proportion, it's then back in the same proportions as P and Q. The other thing that could happen is that the resistance of Q could go down so that the ratio of P to Q now matches the ratio of R to T again, or P's resistance could go up so that by the same proportion, so that it's split. So this one gets a higher share of the voltage, like R gets a higher share of the voltage because T's gone down. So they're your possibilities, and then we just need to check. So decrease the resistance of R. Yes, that's an option. Increase the resistance of R. No, that's not. Decrease the resistance of P. No, P needs to go up. Increase the resistance of Q. No, Q would need to go down.